Thank you very much, Cecilia and Vasco, for the invitation, and thank you everybody for being here and to share with us a couple of minutes to share on this topic. First, I'd like to talk a little bit about the study that we're going to be presenting. So we know that today buildings must adapt to climate change. We face a dual challenge between shocks like floods and storms, among others, and also the pressures related to increased heat waves, and among others. And this is a study that was developed between Arup and Saint-Gobain during a collaboration during 9 months to combine the expertise and to reflect together on what are the potential solutions that we can bring to the market to address this topic of adapting to climate change. Understanding that 80% of our buildings today are going to be there in the next 50 years. So the session is going to be divided in 3 parts. One, we're going to be explaining a little bit of, like why we need to adapt. Then how we can better design for that uncertainty. And then lastly, give some ideas of what are the solutions that are available today for adaptation. So in that regards, let me start with why this topic. Even if today we're talking about, decarbonization, a lot of the carbon that is already in the atmosphere is already locked for several decades. That means that buildings that are designed today are going to be operating in the future in a completely different type of climate. So we have to understand that buildings are both at the same time victims of what is going to happen, but also amplifiers, because they will be impacted by floods, but the way we construct could also increase heat island effect, among other things. So they are the both times, part of the problem, but also part of the solution and impacted. So the question is not necessarily if we need to adapt, but how fast we can integrate adaptation into our design and retrofit activities. So to understand this more completely, let's see how climate itself is changing. So in this slide, what we want to show is that climate is scaling. What does that mean? That not all impacts are linear in terms of increasing temperature. On one side, a 1.5 degrees increase will have some major shift. Among them, extreme heats that are going to be happening more often, heavier rainfall events, more water stress, and stronger cyclones. This means that for 1.5 degrees, the baseline that we have today for designing buildings is already changing. And this has 2 implications. Before, we used to talk about, the 1 in 100-year type of events. And now with these more frequent climate events, we're talking about 1 in 20 years or even 1 in 10 years. We have more events more frequently that we need to integrate into our design process. At the same time, the level of uncertainty is going to be impacting the scenarios we're going to be analyzing. And this will have an impact on the design, on the performance, but also on the cost and the safety of buildings. And then if we move to a 4-degree scenario, everything that I mentioned is going to be even more stronger yet. In terms of extremes will become a norm, events will multiply further. So all of this brings a challenge that we are not designing for a fixed climate, but we are designing for multiple scenarios that will impact the risk of buildings in a different manner. So the truth is that buildings today are still designed for the past, and designing on the past will mean that they will fail in the future based on these activities. So we have to translate and look at different ways of how we adapt to risk in buildings. So one of the things to consider is that buildings are impacted by 2 fundamentally different types of pressures, and that you see here on this slide. On one side, you have acute shocks, which are basically things that are visible, that you can see, that are sudden and have a high impact. For example, floods, storms, wildfires, all of those are acute shocks that happen in one go. And those are usually the ones that we insure. So when we're insuring a building or a project infrastructure, we're insuring for wildfires or flood or storms. But there's another pressure that we're not necessarily seeing drastically, which are the chronic stresses. They're much more slower, but they're continuous, and they're related to increase in temperature, more water stress, changes in humidity patterns. So they don't necessarily destroy or impact the building overnight, but they gradually degrade the performance. So it means that eventually we will need more cooling demand, address differently the way of comfort, and they will have also stress and impacts on the materials and system. And today, most of our buildings are only optimized for chronic stresses, as I mentioned before, for floods, storms, and wildfires, but they're not necessarily optimized for chronic stresses. We have to understand that they're not independent of each other. So when you have a chronic stress, it will amplify an acute shock. So for example, the slow increase of temperature in the future will also make increase the frequency of storms, the frequency of floods, or the frequency of wildfires. So we don't have only a risk problem, but we also have a scale in terms of both of these fundamental pressures, the acute shocks and the chronic effects. To visualize this in an easier way, and there you have a picture of a building, we see that a building is not only exposed to one hazard, but to multiple hazards at the same time. So for example, when you look at the roof is exposed to heat stress, solar radiation, rainfall, and all of this is going to be, impacting, or developing overheating, fatiguing materials, or water drainage. If you look at facades, walls, and windows, they're impacted by rain, temperature cycles, solar gains, and wind. So obviously, these different systems will have, be suffering some mechanical stress, water risk, or thermal expansion. And similarly for foundations, they're going to be exposed to flooding, soil movements, and water pressure, again, impacting the stability. So what we see is that when this is not necessarily a design problem, this is basically a systemic problem that we see and not necessarily a product problem. So what we're trying to convey here is that adapting for climate change has to address a multi-hazard and multi-component challenge in terms of how we address the risk. Because buildings are not exposed only to one type of hazard, but to multiple hazards at the same time. And it's this complexity that is starting to drive new pushes in the market, like example, regulation and financial pressures. So what you see on the graph on the left is the number of climate-related events that they have been increasing since the year 2020. So obviously, we know that this is happening. This is going to be continue happening in the future. And it's not only about the number of events that is increasing, but also about the weight of the events. They're going to become more costly, more systematic, and more frequent. So this is not about projecting the future, but how we can start to design and put things today in the building that will adapt to this. And we see two major forces that are acting on the value chain. One of them being a regulation and another finance. From the regulation perspective, we see that there's more need of a climate disclosure and integration of these activities, things that we're incorporating into reporting documents via frameworks like the European taxonomy or the CSRD, that they're trying to push the market to be more conscious of climate adaptation and what companies are doing to prepare for that. But probably the strongest pressure today comes from the financial part. Why? Because we see that insurance costs are increasing. The risk of climate change is impacting the asset valuation. So there might be considered stranded assets in the future. At the same time, investors are looking into what they're investing on, and are those also going to be in risk in the future. So there's more scrutiny from investors. And all of this is going to impact, obviously, the price of the assets. And this impact is multidimensional. It's going to impact the asset, the physical asset per se, in terms of it's going to be damaged or not. It's going to impact operations. It might impact, downtime or service, create downtime or service disruption. It obviously will impact people in terms of, their safety and their health. Obviously, the environment in terms of floods and other climate hazards, reputation, and from the financial perspective, the economics. It would mean higher CapEx, higher OpEx, and more insurance costs. So we see that these climate risks are moving from a technical topic in terms of what can we do only to reduce this situation, moving from a technical topic to a more financial and strategic decision driver. This is all interesting, but at the same time, we need to know that the whole value chain and different stakeholders need to adapt to make sure that we're integrating and bringing all these topics into the design process. And this brings me to this slide, which basically says that adaptation is not only a building and design challenge, but it's becoming truly a value chain challenge. Why? Because when we see the different stakeholders that we have in the slide, from investors to developers to contractor owners to insurance company, there's a structural problem. And the structural problem is that the costs and benefits among these stakeholders is not necessarily aligned. An example is that the developer is the one that is carrying up the front cost to build the project, but is the operator the one that is bearing the long-term risk. But at the same time, is the insurance company that is pricing the risk independently of what the design of the project we're thinking about. And obviously, regulation goes in parallel where it could exist in the country we're talking about or not. So we see that along these different stakeholders, the incentives, motivations, decision-making process, etc., are not necessarily all in the same page, in the same language. And on top of that, we have the uncertainty of climate data, a lack of standards among this topic, and obviously, as I mentioned before, fragmented responsibilities. So this explains why, despite the urgency and everything that we have mentioned so far in terms of financial pressure, regulation pressure, etc., adaptation has not still been systematically embedded into the design practice of projects. And this brings us to the next chapter. We will be focusing on how the design practices are starting to address this uncertainty. And I will leave the floor to Amelie to continue.
So far, we've seen why adaptation is becoming unavoidable and how climate risks are reshaping buildings. The question now is simple. How do we design in this new context? We are no longer designing for a stable climate, but for a range of possible futures. This means that adaptation is not a layer on the top anymore. It needs to become part of the design logic itself. So to deal with uncertainty, designers are already using three complementary approaches. So first, resist and protect. This is a traditional approach, making buildings stronger to withstand shocks. Second, adapt and accommodate. So here the idea is not to fight the hazard, but to live with it. For example, allowing flooding or managing heat differently. And third, flex and change. So here, this is about designing buildings that can evolve over time as climate conditions continue to change. And in reality, good design is not about choosing one. It's about combining these approaches depending on the context. So beyond these principles, the question becomes where and how do we actually integrate adaptation into the design process? So concretely, adaptation can already be integrated at multiple stages of the design process. There are 6 entry points. So first, understanding risk, with climate risk assessment becoming more quantitative and forward-looking. Second, rethinking architecture. using design itself as the first response to climate constraints. Third, designing for new climate load, moving beyond historical data with stronger winds, heavier rains, or higher temperature acting on buildings. Fourth, managing residual risks, because not everything can be anticipated, especially in existing buildings. Fifth, solution and construction systems, where innovation already provides many options, including nature-based solutions like green roof or rainwater management systems. And finally, digital tools which help manage complexity and simulate future scenarios. The key point here is adaptation is not only one action, it's a set of levers across the entire value chain. But in fact, integrated adaptation raises an important question. How do we balance resilience and sustainability? So at first, it can seem difficult. Improving resilience often means using more materials and then increasing carbon impact. But in reality, the solution is not to over-design, it's to design a smarter way and more targeted way. So this is where innovation plays a key role. So improving materials and solutions to deliver both high performance and lower environmental impact. And this leads to what we call a total design approach. So meaning that resilience and sustainability are not treated separately, but integrated from the very early design stages. So this allows to optimize performance across the entire life cycle of the building. With this integrated approach in mind, let's now move to the next step, solutions. So in fact, there are already many solutions available today, and they can be implemented across different parts of the building. So in the report developed with Europe, we identified the main climate risks affecting buildings and structured the analysis around them. And when we look at solutions, the building envelope and the sites act as the first line of defense. This is where we can already access many of these risks with a wide range of existing solutions. So we can group them in a few main categories. First, thermal envelope system like insulation, thermal mass, or high-performance glazing, which help manage temperature and energy demand. Second, solar protection systems, such as solar control glazing, which are essential to deal with overheating. Third, green infrastructure and nature-based solutions, like green roofs, green facades, or rain gardens, which help with both cooling and water management. For surface solutions, like reflective or permeable materials, which improve the microclimate and manage rainwater. And finally, enhanced resistance systems to better protect buildings against extreme events like floods, storms, or fire. So we already have a wide range of solutions which are existing and that can be combined to address different climate risks. And for us at Saint-Gobain, sustainable constructions mean combining performance, sustainability, and adaptation. So concretely, this means that buildings are supporting health and well-being, they have a reduced environmental impact, and they are more resilient to climate risks. And importantly, this also creates economic value over the full life cycle. And we already have many of these solutions in our Saint-Gobain portfolio today. Across our different brands, we can address a different range of climate challenges, from heat to water management to resistance to extreme events. This includes a solution for thermal performance, solar control glass, and more resistant construction system. So adaptation is not something we need to start from scratch. It's something we can already deploy and scale. But at the same time, there is still a lot to do, and innovation, new way of thinking will remain key to go further. To accelerate adaptation, we also need to mobilize the entire construction value chain. And what we see today is that it's already happening at multiple levels. Industry initiatives are working on defining what resilient buildings should look like and increasingly integrating resilience into certification schemes and labels. Financial players and insurers are increasingly integrating climate risk into asset value and insurability. And in Europe, we observe institutions which are working on integrating climate risk into future standards and design rules. And as Saint-Gobain, we are also contributed to this dynamic by embedding resilience into sustainable construction and advocating for it to become more systemic and measurable. So to conclude, what we've seen today with Timo is that climate impact are already changing the way buildings perform, and adaptation is becoming unavoidable. We've also seen that this creates new challenges for design, but also new ways of thinking with more flexible and integrated approaches. And finally, there are already many solutions available today, and the real question now is how to deploy them at scale. So thank you for listening to us. It was a pleasure to do this presentation. We are ready for questions.